All right, so in this video, we're going to be talking about the domain of functions, right? We're not going to focus so much on the range, but we've had some past experience with the domain of a function. Whenever you're given the function like in a table form, the domain is just it's the list of x values, right? It's the list of inputs that you have. So the domain would be 3, 6, 9, 12 right here. And then this other column is what they call the range. But whenever you're given the graph of a function, you can think of the domain as the list of x values again, but think of it as how far to the left and the right that the graph goes. So for this function, the domain, it's not just four numbers, it's not just two numbers like -6 and 7, but it's all the numbers that the function takes on, all right? It's all the numbers between -6 and +7. So you could say the domain of this function is -6, comma 7 with brackets on it each side. So this just means the set of numbers from -6 to 7. Right? And then the range would be, how low it goes to how high it goes, whatever that is. You could be given the function in like an equation setting, okay? And we know what the graph of this one looks like because it's a quadratic. So I know that the general shape is going to be one of those U shapes that go up and to the left forever and up and to the right forever. So the domain is -infinity to infinity. But the other way, the last way that I want us to start thinking about the domain here is the list of possible inputs. All right, the numbers that we are allowed to plug in for x. And you see on these three functions, there's really no restrictions on the numbers that you could possibly plug in for x. Like you can take every number in the world and multiply it by 8. Or you could take any number you can think of and square it, multiply it by itself. Okay, there's no restriction there. Here it's an absolute value. Again, you can always do some number -4. There's no restrictions there. You're also allowed to take the absolute value of any number. Here it's a little bit tougher to think about, but it is true. You are able to raise any you're able to take 2 and raise it to any power, even though they could be funky numbers, like 2 to the 0.5. All right, it gives a real value, or 2 to the, I don't know, square root of 5 would be a weird one. But you can always take 2 and raise it to some power. So there's absolutely no limits on what number you can plug in for x here. So in these cases, the domain is all real numbers. Okay. But what I want to look at is, some of the ones where it's not all real numbers, where the domain is actually, it has restrictions. We're going to focus in on radical functions this time. So there's basically two rules when it comes to domain. You can't divide by 0, which we're not going to talk about today. And then the other rule is you can't take the square root of negative numbers. All right. So the domain, it's the list of numbers that we are allowed to plug in. And it's going to be the numbers that when you plug them in, you can get a real answer. All right. So I know imaginary numbers exist, but in the context of domain, uh, we're not going to include them. Okay. So it's the list of numbers that we can plug in for x and get a real answer back. That's what we're looking for here. All right, which of the following numbers are in the domain of y equals the square root of x plus 5? So I just want to know which of these numbers am I able to plug in for x? All right, if I take 20 and plug that in for x, I get 20 plus 5, which is 25, and you can do the square root of 25. So, yep, that is in the domain. All right, 5. 5's okay. You get 10, right? And you are able to do the square root of 10. All right, it's not a nice number, Square root of 10 is 3.16. It is a number, though. It's a real number. That's what we're focused in on here. So yeah, that's okay. If you plug in 0 for x, you get square root of 5, which is a real number. All right, here we're going to have to start paying attention. Square root of negative 4, you get negative 4 plus 5, which is 1, and you can do the square root of 1. So negative 4 is allowed. But here's one of them that we cannot do. Square root of negative 9. Or sorry, you can't plug in negative 9 for this x value here. You'll do the square root of negative 9 plus 5, which is negative 4, and we can't do the square root of negatives. That's going to give us an imaginary answer, non-real answer. So negative 9 is not included in the domain. That's the idea. It's one of those numbers that we cannot plug in. 100's fine. You get a really big number under the square root. That's okay. Negative 100 is not okay because you get negative 95, and you can't do the square root of negative 95. All right. We could have also figured this one out by simply graphing it, but we're not. We're going to try to answer these questions without drawing graphs. But we know what the graph of this looks like. All right. It's the original square root function, but shifted 5 units to the left. So negative 5, and then it would have been going up and to the right forever. So the domain of this would have been negative 5 to infinity. It would have been all the numbers greater than or equal to negative 5. Okay, and that's the numbers we circled here. All the numbers that are greater than or equal to negative 5. So you actually can plug in negative 5. Right? It gives you 0, and we are able to do the square root of 0. All right. I'll finish this video off at this point, and we'll talk about how to find the domain of square root functions in a separate video here.